If you searched SSHFS mount remote directory, you probably want one simple thing: a server folder that appears on your workstation like a normal directory. Here is the trap. It feels local enough that you forget it is network storage. Then you run a build, a test suite, or a package install against it, and everything crawls or breaks in strange ways. SSHFS is excellent for quick edits, inspection, and moving through a remote tree with local tools. It is not magic local disk. Today we use it cleanly, set reconnect behavior, and draw the line where it stops being the right tool. SSHFS exists for administrators who already have SSH access and do not want to expose NFS, SMB, or a web file manager just to touch files. It uses the same authentication path you have been building through this series: keys, known hosts, SSH config entries, agents, and jump hosts where appropriate. The result is a mount owned by your user, usually under a directory like MNT in your project folder. Your editor, grep, less, diff, and file browser can operate against remote files through a local path. That is the sweet spot: interactive administration, config review, small edits, log inspection, and temporary maintenance work without creating another always-on file sharing service. Mechanically, SSHFS is a fuse file system. Fuse lets a user space program present a file system to Linux without writing a kernel file system driver. SSHFS receives local file system operations and sends them over the SSH SFTP subsystem to the remote host. That means reads, writes, directory listings, stats, opens, closes, and permission checks become network conversations. Large sequential reads may feel acceptable. Workloads with thousands of tiny files and metadata checks feel awful, because latency is paid again and again. Your normal SSH configuration still matters. Host aliases, identity file, user, port, proxy jump, and host key verification are all in play because SSHFS is still using SSH underneath. Walk the card line by line. First, create a local mount point. It is just an empty directory where the remote tree will appear. The simplest mount form is SSHFS user at host :path ./mnt. Use that when you are testing. For a working session, I like the options shown here. The first ops line enables reconnect and sends a ServerAlive probe every 15 seconds. The second adds ServerAliveCountMax of 3, so a dead connection is detected instead of hanging forever. Then SSHFS mounts the remote path using those options. When you are done, detach with fusermount-u ./mnt. On some Fuse 3 systems, the command may be fusermount3-u. The first mistake is running builds over SSHFS. Compilers, package managers, node modules, Python virtual environments, and test suites can hammer metadata. You will blame SSHFS, but the workload is wrong for it. The second mistake is using SSHFS as a production data path. An application writes uploads there, a service reads configs there at boot, or a database uses it for storage. Do not do that. Use proper deployment, rsync, object storage, NFS with deliberate design, or local disk. Security-wise, never ignore host key warnings. SSHFS protects you only if you verify the server you are mounting. Also remember, permissions are remote permissions interpreted through the mount. Do not assume a local chmod model fixes remote access policy. In the Practitioner tier, SSHFS sits between interactive SSH and file transfer automation. It benefits directly from earlier episodes on key authentication, SSH config aliases, agents, host key hygiene, and jump hosts. It also helps explain why different tools exist. If you need to edit a few files, SSHFS is convenient. If you need a repeatable copy from workstation to server, use rsync or SCP with clear commands. If a service needs storage, design storage. Do not smuggle it through an interactive SSH mount. Later, when we talk about systemd user services and auto-mounting, the same rule will apply. Convenience is fine, hidden production dependency is not. Try this only on a machine or VM you administer. If it runs an SSH server and you can SSH to localhost, create the mount point, then mount your own home directory back to ./mnt using SSHFS. Open another terminal and run findmnt./mnt. You should see a Fuse SSHFS mount. List a few files under ./mnt, create a small test file, then confirm the same file exists in your real home directory. Finally, unmount with fusermount-u. If localhost SSH is not enabled, use a lab VM you own instead. The goal is not complexity, it is feeling the mount, the delay, and the cleanup.
3 beats to keep.
First, the basic shape is SSHFS user at host:/path, local mount point. If you can SSH there, SSHFS can usually use the same identity and config. Second, use it for human scale administration, edits, inspections, small transfers, and temporary access. Do not run builds over it, and do not make it a production data path. Third, clean up after yourself with fusermount-u, and use reconnect plus ServerAliveInterval when sessions may idle. This is SSH Mastery. One SSH administration and defense topic every day from zero to expert. Also check the daily ranked CVE brief, linked in the description.